In this video, I would like to restate some of the properties of the graph of a logarithmic function and also discuss sketching logarithmic functions using transformations. So I want you to consider the graph of y equals log base b of x. This graph must pass through the points 1, 0, and b1. 1, 0, and b1. The reason is because log base b of 1 is equal to 0 and log base b of b is equal to 1. These are two of the logarithmic properties that we observed in an earlier video. So if I mark those 2 points on my graph, 1, 0, and b1, say I'm sketching the graph of y equals log 3 of x. I can mark my two values at 1, 0 and 3, 1 and sketch the logarithmic function based on those two values. You will recall that this is the inverse of the function y equals 3 to the power of x. And because it is the inverse of that function, every property of the x and y values are interchanged here. So y equals 3 to the x looks like this, with a horizontal asymptote at y equals 0. That means the graph of log base 3 of x will have a vertical asymptote at x equals 0. We also stated that the domain of a log function is from 0 to infinity, not including 0. And the range of a log function is from negative infinity to positive infinity, all real numbers. This is assuming that the log function has not been translated to the left or the right. Just like an exponential function may have its range change as it moves up or down, a logarithmic function may have its domain change as it moves to the left or to the right. So having noted some of these properties of the graph, let's look at an example of a transformation. Let's sketch the graph of y equals log 3 of x plus 2 and label any intercepts. Well, once again, the graph of y equals log 3 of x is the toolkit function here, and that passes through 1, 0 and 3, 1. So we'll recreate this toolkit function and then consider the transformation. The transformation here is affecting the x values, and all of the x values are moving 2 units to the left. So when I sketch our new graph, y equals log 3 of x plus 2, instead of a point at 1, 0, we're now going to have a point at negative 1, 0. Instead of a point at 3, 1, we're now going to have a point at 1, 1. So it looks like my logarithmic function has this shape. Let's also think about the vertical asymptote here. There used to be a vertical asymptote at x equals 0. That also got shifted to the left 2 units. And so I'm going to draw with a dashed line a vertical asymptote at x equals negative 2. The graph approaches this vertical asymptote, but never touches it or crosses it. Finally, we were told to label any intercepts of this graph. One of them is quite obvious. This is one of the points that we translated, and that is the point negative 1, 0. The other one is more difficult to state, the y-intercept here. What value is this y-intercept? Well, we know that the x value must equal 0, and we can plug in x equals 0 to get an output value for y. When we plug in x equals 0, we get y equals log 3 of 0 plus 2, which is just log 3 of 2. I need to remember that this represents a number. This is an exact value for the y value of the y-intercept. So I can write this as a point, 0, log 3 of 2. Somehow it doesn't look very satisfying to leave it in this answer, but any decimal form that I give would only be an approximation of log 3 of 2. If I keep it in this form, I am giving the exact algebraic value for that y value. Finally, this graph has a domain of -2 to infinity, and it has a range of all real numbers.